Hello everyone, welcome back to Programming in Python Learning Series, and this is Session 10. In the previous sessions, we went through the introduction, flow of control, functions, strings, lists, tuples, dictionaries, and exception handling. In this session, we look at file handling, what are files and how to deal with files in Python, and the rest of the topics in upcoming videos. So, what are files and why we need them? We would have come across so many forms of files: text, documents, PowerPoint, Excel. All of them are files in the computer world. And we would have used them in many ways: image files, video files, audio files. All of them are files. So, what are files actually are? In technical terms, a file is a named location on a secondary storage where data are stored permanently. For example, I have a program which is expecting an input from me. I'm giving the inputs and it's running and showing the output on the display. After execution of the program, what happens to the data I entered and what happens to the data the program is showing as output. We need to have a place where I should be able to store the input that I'm giving and the output from the program in some place, so that if there is a need for me to look at what was given as an input and what came as output as a reference or validation, I need to have those data stored somewhere permanently. This storage is called a file. It can take various formats, but fundamentally, a file is a named location on a secondary storage outside the program execution. As I mentioned earlier, the data entered while executing programs are lost after the execution, and the output from the programs alone are available on the standard output device. I still don't have a place, or I still have not defined or found a place to store the output. Once I come out of this controller, I close my compiler process, that output data will also be lost. So, files are useful there. To reuse input data and the program output data, there needs to be a storage location. What if I want to run the program with the same input data that I gave earlier? Something might have changed based on some dates. My program logic can deal with the input data in a different way, right? So in such situations, my output may be different, maybe not, but I still want to check. So I need to have a place where my input data is stored. After the program execution, whatever is coming out as output from the program should also be stored somewhere. Python programs are also stored in files with py extension. We saw that in previous sessions. Whenever we had sample programs executed, we stored all the programs in .py files, which the ideally can identify and interpret. Types of files. First, we look at text file. Text file is a data file containing a sequence of characters, which can be alphabets, numbers, and special characters. These may have extensions like .text, .py, .csv, .dat, etc. One thing we have to remember with text file is these have just the characters. They may not have formats or fonts, settings, color settings, and so on. So these are just plain character files in any of these extension formats. Values are stored in binary formats, sequence of bytes, either ASCII, Unicode, or any other encoding scheme is used. While reading the data from the file or while opening the file, the editor translates the encoded character into human readable format. For example, any text that we enter, when it stores, it will not be readable if we actually could see that. But when we open the file in editor like Notepad or TextPad or whatever, the editor translates those binary characters or ASCII characters into human readable format, which we can read and understand. Each line is terminated by a special character called end of line. In Python, the default end of line is \n, but it can be set as a different character also with programming. Contents within text files are usually separated by space, comma, tab, etc. I mean, these are data elements. The entire line is terminated or ended by an end of line character, but each data element is separated by space, comma, tab, etc. The next type is binary file. Binary files are stored as bytes in the binary format. They are also stored as bytes. These bytes represent actual values of the not the encoded value. Some examples are audio files, video files, executables, compressed versions of files like WinZip files, and so on. These are all binary files. These are not human readable. Even if you open or try to open with an editor, we'll not be able to see the actual characters. I mean, human readable characters. These will be just looking like junk. These are not human readable, hence need a specific software to read the binary file. For example, audio files we cannot actually see, but if we have an appropriate software, we can listen to the audio or music. Similarly, video, if there are players, MP4 players or any other video players, we can see video and listen to the audio. Executables we can run on systems, however, we'll not be able to see what is actually present there, and so on. Binary data are stored in a sequence of bytes in the file. Even one byte is corrupt, the file becomes unreadable for the supporting application. These have to be handled in a very particular and safe manner, because in the case of text files, right, if we make changes or we open the file and make changes, it's not going to impact the operations of the file. We can still read from or write into the text files. However, in the case of binary files, for some reason, if a particular bit or one byte is corrupt, the entire file becomes unreadable, or it will throw up some unexpected information or data which will be completely wrong. So we have to be very careful with how we deal with binary data files, and it's very difficult to remove those errors from the binary file. In the case of text file, we realize that there is something wrong with the data. Say I'm using that into uh, processing something else and I find something wrong, I can come back and change it. But identifying the error in the binary file itself is a problem, let alone removing the errors. Both text and binary files can be read and written with Python language. So we'll see how to do that. How to open and close files. For doing any operations on a file, first and foremost, we need to have the file present, created, and then open the file for any operations, either reading from the file if it is already there with data, or write into a file with some data as input. So first and foremost, having the file present and opening the data. Let's see how to go about them. For opening a file, Python uses open function, returns a file object called file handle that is stored in the variable file underscore object. The variable can be used to read from or write into files with the functions from Python's IO module. This is the starting point. This is the key. Anytime an open function is used, open is called for, it creates a file handle that is stored in a variable file object. This is basically a reference, a position reference or location reference. This file handle is a reference in the memory which is stored in the variable file underscore object. If the file does not exist, Python creates one with the name given. Say I want to open, for example, a file name .open. If the file exists, the file is opened. Otherwise, it creates a file and gets ready for file operations. Attributes of file object gives the basic details of a file. And file.close returns true if the file is closed, else false. File.mode returns the access mode in which the file is opened. Did I open with read only or write, and so on. File.name returns the name of the file. Full path is needed if the file is not present in the current working directory. These are some attributes of the file object, the variable that we saw earlier. Say for example, the file object dot closed will return whether it's true or false. Let's see some of the access modes that are available in Python. It's an optional argument to specify the mode in which file should be opened. There's a table for quick reference. Let's see some of them. Read opens the file in read only mode, and the offset position or where the operations can start, or how the file is opened and which location the reference will be. It's at the beginning of the file. RB is read only binary. R plus R opens both in read and write mode. W is for write mode. If the file already exists, contents will be overwritten. If not, a new file will be created. WB plus or W plus WB, it's opening in the binary mode for writing. Similarly, a file already exists, it will be overwritten. If not, a new file will be created for writing. A is for append. See, the write and append are two different entities in the case of writing. Say W will overwrite whatever is there in the file already. In the case of append, it's not going to remove anything, it's going to start adding to the end of the file. So your positioning, or the memory positioning when opening the file, will be at the end of the file. A plus or plus A will be append and read mode. If the file doesn't exist, a new file will be created. For opening a file, the syntax is object name equal to open of the file name in whatever mode we want to. Opens the file in write mode if exists, else creates a new file with the name given in the write mode. So in this case, if it is not there, it's going to create first file.txt. Opening a file with class. With open, file name, access mode as file object. When the file is opened with class, it is automatically closed once the control comes out of the class. This will be helpful in case we open some large files, we deal with the data and we forget to close, right? And it might be sitting in the memory, or it might even interfere in some of the operations. So this particular syntax with open of a particular file name and an optional access mode will make sure once the file operations are done, the file is closed. Closing a file, the syntax for closing a file. Close function used in Python. Syntax is file object dot close. We have to remember the file object is the object that was returned from the open function while opening the file. Python flushes out unsaved or unwritten data before closing the files to make sure memory used in the file operation is released for further processing. This is one of the key features in Python. If the file is reassigned to some other file, then the previous file is automatically closed. Say a reference is passed on, or the information is passed on to another file, or control is moved to another file. The file that is currently open will be automatically closed. Now let's look at how to write into a text file. To write into a file, the file should open in write or append mode before the process starts. Remember, we saw the table. Write will overwrite whatever is already there if the file exists, and append will keep adding to it. In both cases, if the file does not exist, what the file name that we provide, there is no file in that name, it's going to create a file in that access mode. In write mode, the existing data is erased and the object will be positioned at the beginning of the file. In the case of append, the positioning will be at the end. After opening, methods used to write are write for writing a single string at a time, one word at a time, or string at a time. Write lines for writing a sequence of strings. The write method takes one string as an argument and writes into a file. And it returns the number of characters being written in a single execution of write. For example, I write a string. The string will have so many characters. For that write instance, how many characters have been written in that one string? That will be returned by that function. New line characters should be added at the end of each line. This is mandatory in the case of write function. So I'm opening the file in write mode and I'm writing. I have started using files in Python /n. This is the whole string. Within double quotes, I have the whole string and a new line character. So the entire text within double quotes as one string will be written in this call of write. So I have 36 character written into the file myfile.txt and that is shown as the output after the execution of my object.write. And I'm closing it with the close function. The write method returns 36 the number of characters, and the end of line is counted as 1. The slash n together is counted as 1. Numeric data are converted to string before writing into the file. Data is written onto a buffer. When the close method is executed, the contents are moved to the file located on the permanent storage. See, during the process of writing or during the execution, until the close happens, the data is not actually written into the file. It is there in the memory buffer. So something happens, the program crashes before the close of the file. Nothing is going into the file. Only when the program encounters the close, the data is written into the file. That's where using with open helps. Even if we forget to close, the with takes care of closing, and the processor, whatever we did on the data, reading from or writing into file, all that will be made sure are done, and the data is returned to the file. And the next one is write lines method. Takes iterable objects like list, tuples, etc. Remember, we saw that write lines deals with multiple strings, not just one string as the write. It can deal with multiple strings. So wherever we can have multiple things as strings as storage, like lists, tuples, dictionaries or sets, these containing multiple strings. Any object that can contain multiple strings will be taken as input. And this does not return number of characters because it's multiple string, and every we can it need not be counting character uh, from each string and give that as an output. There's no need for it. For example, open my file context in write mode, lines equal to hello everyone, write multi-line strings. This is the third line. I have three strings and two of them having new line characters. So it should show me three lines. First line with hello everyone, second line with writing multi-line strings. The third line with this is the third line. And I call the write lines function of lines which hold the multiple strings. In this case, I have a list and I'm closing it. This is how the output looks like. Next, we will see how to read from a text file. To read from a text file should be open in either of read plus, w plus, or a plus before the process starts. These are the methods for reading. One is read. To read a specified number of bytes from the file. Say I say read of 10. 10 characters will be read from the file. Read line n reads one complete from line from file where each line terminates with the end of line character \n. And it can also read a specified number of bytes up to the new line character. So the n is optional, but by default, it can read one line till the end of line character. And read lines can read all the lines and returns the lines along with the new line character. It's basically, it returns whatever is there in the file. Let's see the syntax and some examples. Syntax for read, file object dot read of n. Here I have a file tryexcept.py that is already created and saved. So I'm opening it with open in the read mode, assigning that to my underscore object as the file object. In this, I'm going to read 50 characters. So print exception handling try block and slash n try slash n. That's the 50 characters read from the try except. It might hold more than this, but my expectation is to read first 50 characters from that file, and I'm closing it. The next example shows what happens if I don't give the character count. I just say my object.read open and close parenthesis. It prints the entire content of the file. I'm saying print, so it's going to open and print all the data that is present in the file, and I'm closing it. So there is no restriction, there is no new line character in being entered and so on. So it's just printing the entire stuff. Next is the read line of n. Here's an example. I'm saying read line of 30. It's printing the 30 characters without the new line characters and close it. Unlike the read function, here the read line without any character count still prints only one line till the end of the line. So there is a difference we have to note. The next is read lines. Remember, read lines can read multiple strings and multiple lines and print what is there in the file as a content. So I'm assigning my object to a particular variable, and for each line in that variable or the object, line split the lines and print those statements. So in this case, I'm going to get each line as a list item. This will be useful in case there is actually a data that needs to be processed, and each line will be printed as a separate one. Next, you'll see how to give offsets while reading or writing into a file. There are two methods given in Python, seek and tell. What is the need for having offsets? For example, I need to start reading from nth character or nth line in a file. I don't want to read from start. We need to have an offset possibility, right? Skip so many characters or skip so many lines for me to receive the data. So seek and tell help in setting offsets. Here I'm opening a file, text fl.text in read plus mode. I can read and write and assign the read into a string. Whatever I read from this particular file, assign to a string and print that string. Meaning, whatever I read from text dot underscore fl.text, print into the display. Then print initial position of the file object in tell. Call the tell. Tell gives you the current position of the file object or the initial position of the file object. Now I'm going to seek with the offset of 0, meaning I want to start from the beginning of the file. Wherever the current position is, I want to go to the beginning of the file. So the file object is now at the start of the file because I was seeking for the position 0. So tell is going to actually kind of give me the current position. That's the function of it. Now I'm going to seek or I'm going to set the current position at 10 with the seek function. So print moving to 10th byte position from the beginning of the file and tell me where the object is. This is to kind of making sure what we are trying to do is actually happening. Now assign the read into the variable str and print str. So it's like doing it twice, see where we started and where we are ending with. And here is the result. First time initial position of the file object is 17, and since I was using the seek function with offset of 0, the file object is now at the start of the file as 0. The tell gives me the current position which is 0, and moving to the 10th byte position from the beginning of the file. That's a message I'm printing, so it's going to print anyway. Because I was seeking to move to 10th position or 10th byte from the beginning, the position of the current file object is at 10 with this second tell function. So tell gives you where we are at now, where the file object is now. And seek is to position the object into a particular byte position that we actually want. The pickle module. To save any structure along with data, Python provides a module called pickle. We saw earlier in previous sessions that Python has so many inbuilt modules with lots of function in each of them, right? So you have some reusable functions which can be used over and over. You don't have to write those functions. Similarly, a group of functions can be put into a module which can be imported and a particular function can be called to do its operation. So one such module is pickle provided by Python. Serialization is a process of transforming data or an object in memory to a stream of bytes called byte streams. You have to remember this particular terminology. Serialization is a process of transforming data. I have multiple data elements and I'm going to make it as a stream of bytes called byte streams. That's called serialization. This serialization process is also called pickling in computer terminology. So Python has a module called pickle module which helps in serialization process. Deserialization or unpickling is the inverse of pickling process where byte stream is converted back to a Python object. We had an object and I made it was byte stream, a sequence of bytes, and now I'm inverting that stream of byte or byte stream into a Python object which I can use it anywhere in the program. The pickle model deals with binary files, not text files. Here, data are not written but dumped, and data are not read but loaded. So we have to remember it's not the reading or writing process. It's like the whole data, it's either dumped or loaded from. A serialization or deserialization process, you dump the data or load the data into your object. The pickle model must be imported to load and dump data. Obviously, so any if you want to use any module in Python, we need to make sure it's imported at least once in the Python program. The pickle model provides two methods to work with binary files for pickling and unpickling, or serialization and deserialization. Dump is for pickling, serialization process, load for unpickling. This dump function converts Python objects and write data into a binary file. The target file needs to be opened in binary write mode. We have to remember this because this is a byte stream and the file should be opened in binary write mode. Here's the syntax: dump the data object wherever it's coming from and the file object, the Python file object into which we are going to write the byte stream. The file has been opened in binary write mode. Here's a sample. I have list with values like list elements like one SSK. This is like number one, name, male, 26. So I'm opening a new binary file or existing binary file, my binary data. If it is available, it's going to open. If it is not, it's going to create. And pickle.dump of list values into the binary file that I created that is assigned or referenced with the FL object variable. So this dump takes care of writing these into FL object and I'm closing the file FL object. Now I'm opening the file, the binary file, the dat file in read mode and printing the values. So what will happen? What we can expect here? As we saw earlier, this is byte stream or binary data, and we are not opening into an editor. We are not opening with the appropriate software, so it's going to be looking like junk. And load is for unpickling, meaning deserialization, taking up a binary file, reading the byte stream, and convert it into a file object for Python to use. The file to be loaded needs to be opened in binary read mode, obviously, right? The syntax is a store, an object variable and load the file object. So here is an example. Open the binary file mybinary.dat and load the data from that particular binary file into a Python object obj underscore var and close the binary file. Now just print what is read from the binary file or the mybinary.dat onto the display. And this is what we see. Quick recap. File is a named location on a secondary storage where data are permanently stored. Each line of a text file is stored as a sequence of characters and is terminated by a special character called end of line. Binary file consists of data stored as stream of bytes. Open, close, read of n, read line of n, read lines, write lines are methods to perform read and write operations on a file. Tell and seek are methods to perform offset operations on a file. Pickling is a process used to convert a Python object into a byte stream. Dump method is used to write data into a binary file, and load is used to read data from a binary file. Now let's look at some sample programs that you can try out. Please do try and see how things come out. Write a program to accept string or sentences from the user till the user enters end. Save the data to a text file, then display only those sentences which begin with an uppercase alphabet. Write a program to append text to a file and display the text. Write a program to read a file line by line and store it to a list. And write a program to read first n lines of a file. And of course, you can try out a few by yourself. You can always find problems to be solved using Python programming. Please do try. See you in the next session. Thank you.